Hello. Just getting started. Finding all my windows. Alright, let's do it. So, what are we up to today? At the end of my last stream, we did a lot with preloading composition and inverse relationships. Covered a ton of ground. So, at this point, it's possible to express in some code this way to say I want to fetch some users, and along with those users I want to fetch these related tables, all their to-dos and all their tags that they've created in an app. Or I don't know, I'm imagining a weird to-do list. I feel like I'm just inventing a nonsense schema, but one that's at least somewhat related to schemas I've encountered in the past. Or maybe there's a task list, and you have to-dos on the list. You have you can tag the to-dos with different, I don't know, urgent or easy. So I can create tags in this app that I can assign to to-dos. I can create to-dos in this app, and I can associate the tags and the to-dos with each other. But in this case, we're for a user fetching all the to-dos and all their tags. Maybe this is for a dashboard or something, so you can see all the data that you've created. And then here you can glue this all together. So first you define that the things that you care about the user, which maybe this would be a more sensible syntax for this is to inline it. But there's a lot of sort of ergonomics that I've yet to figure out here. You can say for the users I need their to-dos, I need their tags for all users. And then here I'm just printing them all out. And then down below I can also do the same for an inverse thing. And some of the cool stuff that I got to at the very end is that so if you look here, we're just loading to-dos. Here we're loading to-dos and tags. And so this one is the interesting case. Maybe I'll grab this and paste this into my editor. You can see that for this user who's someone at email.org, we can see that we load the to-do, and then on that to-do, we set the user back to this same user. We have the back references, which is something that I don't know. I find that always valuable everywhere. And one thing that's very reassuring is that they're all the same pointer address. We can see these things all reference each other correctly, which is awesome. You can navigate those cycles. And so if you have procedures that you want to call that are sort of scoped to a to-do that manipulate that to-do's user, and you have procedures that you want to call scoped on a user that manipulate the to-dos, and procedures that you call that start from a tag, you can load a whole, I don't know, some ORMs or systems might call this a document. You might hold this load this entire document of a user with associated to-dos and tags and other bits of data that you want, and they're all referentially consistent. So you can mess with the whole thing and then do whatever sort of write operation you wanted to based on the whole world being consistent, which seems exceedingly valuable to me. But and maybe this is kind of obvious. So the value of these tags is that they actually belong to to-dos as well. And so maybe the coolest thing to do here would be to say, give me I want users with their to-dos and their tags, but on their to-dos I want to know taggings, so an association between that to-do and a concrete tag that was created by a user. And that kind of walking multiple hops in terms of preloading data isn't implemented. So that is where I'm headed. So it's going to be a little bit like a composed preloader, only it's going to be like nested. No, don't save that. Delete that. Don't save. Here, let's call it nested preloader. And like, how exactly is this going to work? This is going to be like, this is going to be hard. This is going to be hard. So maybe we should talk about some like idealized syntax. That was a useful thing before. So this was like brainstorming syntax on how to get to where we are now. Not this, not this, not this. This though. Yeah, okay, and I did sketch out some thoughts on like nesting. And I thought that maybe you would compose a preloader and nest multiple and throw them all together like this. Okay. And so at its core, we have this user has many recommended to-dos, to-do has many tags, and we're going to know how to glue these together and say that like this relationship is going to get preloaded, and like as we get this list of all of the to-dos which haven't yet been associated to users, we're going to decorate them with more stuff. Let's like find that code. Right, so here, this preloader behavior is like we preload the results from the left-hand side and the results from the right-hand side. They're all grouped up. We just go at it. Yeah, and so I think like the way this is going to play out will be, in the case of this has many, I think maybe I'll just like try it. I think I'm just gonna get started writing code to match this API and like see where it takes me. So let's go for preloaders, and let's open up compose preloader. All right. So what goes into a nested preloader and how's this gonna work? Parent. Child. This seems about right, you know? It'll be like some like root data that we're like decorating with these like children. That seems like reasonable. And a child might be like a composed preloader, but either way, it's going to have a source and some other stuff. Yeah, okay. Okay, and what are the things that this needs in order to operate? What fields do we expect? We need preloader. There's some preload. We'll just like stub this out for now. The other bits that we need. So here we surely need a source, a destination, and names for each of these. Okay, let me just like think about this for a sec. Because like, how does this play out in composed preloader? We're like deriving the destination type Yeah, okay. Did I do any sketching on what I think the type that this will return is going to look like? I don't know if I did. Right? Some of the composed mess. Yeah, so I like glued things together in this really nested way over here. Oh, doorbell. BRB. UPS delivery. All right. Okay. I was trying to think through what this type is going to look like, and my brain is moving slow. It was maybe trying to write code today was a mistake. I don't know if I have it in me. All right. So like what we get with a normal preload is that we can go like user 0 dot to do 0 dot something, right? Dot like description. And it's because like this type is something that has like, I don't know, the user has like an email. Then we have a like to-dos, which is like a array, a pointer to to-do, to like struct. Yeah, and then here we have like a description, which is like a string. And like maybe this is boring, right? So what we have here is like using user. And really this is like using to do, which like gives us that. And now what we want is something effectively like taggings. And these are going to map to something using, or maybe this will just be like actually taggings at this point. Yeah. Well, but it'll be like inverse, right? So, and like, okay, so something like this is like the reality of what we're looking for here. So we can do like, oh, but a tagging doesn't even have a description, right? A tagging has like a tag ID. Right, so for this to actually be useful, we're gonna have to go one deeper and say that using tag, right? It would be like tag. There, okay. Okay, so this is like roughly the structure that we want this thing to eventually result. So the preloader, the like to-dos, the has many preloader does like this big chunk. Right? Like what's like the nested bit decorating this with? The nested bit is going to be decorating these to-dos, yeah? It's going to be taking like each to-do and like adding some stuff. So the source, we need to do some asserts here. So we need to assert like parent dot destination equals child dot source. How does assert work? I think we need a semicolon. Right, okay. I feel good about this, yeah. And then we need some other funny business here probably where like parent dot what, like destination name equals child dot source name. For these things to all line up correctly. Except there's like pluralization issues there. That probably won't actually work. So let's just assert that much and we'll see how far we can get. Okay, so source here is it's definitely going to be parent source. I think this destination is like who knows yet. And this is going to be computed, but the source name is not. Yeah, maybe I'll just go like parent child. Maybe this feels better. I don't know. I think that I'm mixed on, right, like all these like runs that happen here. Like maybe they'd be better suited here. Like this is like a constructor. Right, and so this becomes just like a dumber struct instead of a thing that like, this is like effectively like shimming in like initialization behavior with run directives on static data. Which like, right, I've already got this thing which does the important work. Like maybe this thing should be less clever. I don't know. This is working just fine though. I'm gonna leave it as is and think about things from here. I also want to hear my music. Cool. Okay, so what do we think happens next? Preload is easy. We need some destination type, which is gonna be basically it's just gonna be child at destination, yeah? I don't know. That sounds right. That sounds right to me. Right, because we're going to take all the things of this like parent type and then apply this thing to them. Yeah. I don't know. Let's think this through. Okay, what am I thinking? I'm distracted. Distracted. Someone sent me a link about Jeff Bezos. Am I about to get furious about a billionaire? Yes, I am about to get furious about a billionaire. I'll do it quietly. Okay, how does this even work? I think I'm starting this all kinds of upside down. So maybe I'll start with a spec. Maybe that'll help. I'm going to comment this out. I'm going to try some TDD. I'm just going to say, like, what's like the least I can write that'll make this like pass the build? We're probably close. What's the signature on this got to be? Pre-nested preloader. Source records. Oh, this can just be source, can't it? Didn't we flatten that out a bit? We did not. Yeah, we did. Okay, cool. Right, and yeah, this is like we in some cases like arbitrarily pick one, in other cases we don't. Right, like okay, I'm gonna at least make this a little bit consistent. And this is left-hand side dot source name. But like I think this is a real smell. It seems pretty clear that we really don't want. Like we should be doing all this work in compose preloader, I think. Yeah, we'll get there. We'll get there. Okay. The weird thing is that we need to leak left-hand side and right-hand side. We need to like hang on to them, right? So like a lot of this is just to maintain a public API that's consistent with other preloaders, like these two, so that we can like describe this behavior and stuff. But like the business in here, like we need left-hand side and right-hand side defined. Anyway, okay, nested preloader at source goes here, and then this needs to return a bracket of preloaded result of nested preloader. Okay, but I can just have it return an empty list for now, and I think it's fine. I don't know. Cool. I think this meets the API. Alright, so let's create a spec. Let's start with compose preloader spec. Try to make heads or tails of this. I think it's going to be much easier with some example code consuming it. I'm going to need all this for sure. This is now nested. Great. Okay. And so for this, I don't know. Let's like do this story that I've been talking about. Maybe I'll just go from tags, from to-dos taggings to tags. That seems like enough. So a to-do is a struct of ID, description. I don't care about anything else. Tagging is a struct. ID tag to-do ID. Tagging ID. And a tag is a struct of ID. Description. It's got like a user ID. I don't think it's even worth talking about that right now though. That might cause problems for us, but I don't think it will. To-dos repo is run repo on to-dos. Taggings repo. Okay, we got our repos. I think we need to declare some relationships. And how many of these relationships do we care about? Like, do we care that like inverses are set, or do we trust the things that we've delegated around to make sure that inverses get set properly? I don't know. Let's define the relationships. Why not? Throw it here. To do has many taggings. Is a belongs to. Yeah, just like this. I'm just gonna steal this. I'm not gonna throw in the inverse of for now. Great. And then taggings repo. Tagging belongs to tag. Great. And then that's all we need, I think. Yeah, we'll pause there. Okay. Clump these together a bit. Okay, now we gotta insert some fixture data, and then we can run this thing. Okay, so insert result once again is gonna be a struct, just an ID. Great. To-dos, serve results, gets, execute. Do I have a connection yet? No. Grab this. I'm going to execute on connection with type insert result. I don't need any args. Alright, insert into to-dos, just description. And the first one is going to be like to do with taggings. The second one is going to be to do with no taggings. Returning ID. Great. And this next one, so to do with taggings ID, gets to do's insert results 0.id, to do with no taggings ID. What's that? Okay, now some tags. Great. Insert into tags, description, values. I don't know. Let's just do this. Great. First tag ID gets tags insert results 0.id. Alright, so far so good. Okay, and then I don't care about these results, but I want to execute connection. I'm going to need some IDs here. Okay, insert into taggings. To do ID, tag ID, values. Let's say that this first one is tagged with both and the second one has none, right? So 1, 2, 1, 3. We need 3, so we need to do with taggings ID. First tag ID, second tag ID. Okay, so I think this should create 2 to-dos, 2 tags, and then associate both the tags under the first to-do. Done. Whew. Alright. I'm just realizing that, like, because I haven't defined all these types, like, the codebase won't even run, but that's fine. Alright, so preloader is gonna be nested preloader of taggings. Okay, I want to do. Let me try to fill up this whole thing. So preload. This is gonna be to-dos with taggings, and tags is gonna be preload some preloader which I don't know how to define yet, on todos repo.all for some this, and we'll call it like is test to do is a SQL where of id in question mark with one arg, and then I can do test id is a dynamic array of type any. Array add test IDs to do with taggings ID and with no taggings ID, and then is test to do arg0 gets that. Okay. Okay. So then this, if we wanted just the taggings, we would say to do has many taggings, but we want a nested preload which also does stuff on taggings, so we want nested preloader of that with tagging has many, oh no, tagging belongs to tag. Yeah? Is this about it? And I think this is going to have to be in a run. Yeah, that sounds about right. Okay. So I bet even now we like can't build, but let's like figure this out. So we should like expect to do's with taggings and tags account to equal 2. Let's see, do we even get this far? No. I probably have a missing semicolon. Oh, I have, what even in the world is that? How did I even get that out? What is possibly, how did that even happen? Alright. Parse the declaration, so expected a semicolon, we saw this instead. Nested preloader spec, line 24. Oh my god. I am the worst at semicolons. Scripted languages have really ruined my ability to pay attention to details. Which execute is lacking a semicolon? None of them. They've all got semicolons. Where am I missing it? Line 102. It wasn't execute, it was expect. Okay, description doesn't have a string. Line 42. I promise I've written code before. What? Oh, every time. Alright, is tested at arg0. Huh? Oh my god, again? I really struggle with data on the stack. I just, it's been like 10 years since I've written in a language that has stack-based storage. Okay, nested preloader spec, nested preloader, main needs to import it. Now what's happening? Colon, what is that doing there? It's like I've never seen, oh. Okay. Curious. So, it seems like this should work. Let's like print some stuff, yeah? Parent, parent.source, child.source, destination.source. I'm gonna call it parent.destination. Parent.des child.source. Oh, I have to obviously run that in a run. Where did that space come from? Okay, what have I got? I didn't even run that? Shouldn't run this before the assert fails? Okay. Parent belongs to parent.destination is just called capital D destination. Tagging. That's right, because destination is this like surprising weird derived type, right? Yeah, maybe I'll get rid of that assert. That seems hard to do. Because especially with inverses and stuff, these types are going to be like really just munged. Like, I think if we knew that everything was always repo based, but like in many cases I bet these things are going to be composed in a funny way where like we're not even going to know about destination repo and stuff. I mean, I guess in this one case we could depend on destination repo, but I suspect that like so could parent ever not be I'm trying to think if there's ever a reason why you would do so like the way that I've spec'd it, we happen to have this, which is like a true like a base level one of these. But like is there ever a way there might be some cases where you want to be really clever and like I'm trying to think like is this valid where we would run something like this. Like, is this valid? And if so, what would that even mean? Like, what are the actual like guarantees that we need to make about like the relationship between this preloader and the thing that we're nesting under it? And like, and I certainly think it's valid to say like this. Where it's like this one certainly won't have repos, so we won't be able to like inspect the source repo of it for stuff. Yeah, I think I'm gonna get rid of that assertion for now and just say, like I don't know enough to make that safer. And we'll just hope for the best. And like assume that like other things are gonna fall apart if these types don't align. Okay, parent, child. Yeah, these are the wrong case. Alright, source is not a member of preloader. Okay, so source is gonna be parent dot source. I don't know. Call it destination, child dot destination. We're gonna need something else. Source name. Destination name, I don't know, why not? Destination name is gonna be parent.destination name for now. It's gonna be something super weird though, right? This is gonna, here's where we're gonna like, just like run nested something. Like we're gonna need to like play with this. And like the destination we're gonna need to like glue together a couple things. Alright, wait, what went wrong here? Preloader to destination, capital D destination is not a member of nested preloader, isn't it? Destination. Isn't it? Isn't this it right here? Okay, cool. User ID and to-dos. Yeah, okay. I need a user so that I can associate the to-do with a user. Alright. I get it. users insert results gets execute. Insert into users, email, I think is all I care about. Values, test user at email.gov. Returning ID, SQL, no args, and user ID gets the first. Users insert results bracket 0.id. Alright, so now I have the user ID, I can sneak that in all over the place. And I think the same is going to happen down here. I need the user ID here as well. Alright. Okay. Email. I was so close. Alright. And now just my expectations fail. Expected it to equal 2 got 0. Interesting. Wonder what that means. Oh, because I bet my preloader returning nothing. What? That's funny. Oh, yeah, because this top level is preloading, and I'm just always returning an empty list. Yeah. Okay, so let's figure this out. Let's fill in this body. So, okay, parent. Okay, what am I looking for here? I think I want to like run the parent preloader. Similar to how this gets started, but just like running that, right? So like parent preloaded gets preload on nested preloader dot parent and source records. And then, okay, here's where things get really weird. So here, these composing results, it's almost like I think I need to split up my preload abstraction a bit now in order for this to work. Like I already needed to do one pass to support composition. And I think in order to support nesting, so like the base level, so all of these really, but especially the base level ones, define, there's like, in order to support inverses, there's like an associate, which is separate from a preload. And so I think maybe I want to call these like two concepts. I'll call like fetch and then associate. Right, because there's one thing where, okay, yeah, right? Like this like preload function, this preload procedure, builds up a SQL where, iterates over, like, right, so it iterates over the source records, collects all the foreign key information it needs, and then glues together the, that into some SQL to issue a query, and then it just has a list of destination records. And then here we like associate them together, we like group them up by their foreign key and assign them to the correct spot. And I think that we need that like split here. I don't know how that's going to work on the composed case, right? Like in the composed case, what is the result of a fetch? And what is the result of an associate? How do these things even work? But let's go one step at a time. Right, but like I really need to be able to say like fetch, right? So let's think about this. Okay. I mean, alright, so the first step is just like fetched is going to be preloader.fetch on preloader source records. And then like return like preloader.associate preloader with source records. That seems fine, yeah. And maybe I'll like call these. I'll like do that, right? So then I have like preloader fetch. Just gonna take a preloader source records. And what's it gonna return? Ooh, this is gonna be really weird, right? Preloader.destination? I think, yeah. Okay. Yeah. And then source records. I'm gonna need like destination records as well, right? So this is gonna be an array of preloader.source. And this is gonna return the preloaded results for the preloader. Yeah? This can't be, it can't be that easy, right? Preloader associate. So I don't know if these two are like helpful in the longer run, but who knows, maybe, right? Okay, so now I gotta go to each. This no longer has a method called preload. It's gonna have a fetch, and then it's gonna have an associate. So this is because I think that the inverse business happens like entirely in the associate step, right? Yeah, okay, so fetch gets belongs to fetch, which is yet to be defined, and then this is gonna be associate. Okay. And then here, fetch belongs to. Doesn't this work now? Right, because like source here is going to be set to source repo.record. Yeah, I think I can use a little shorthand. Great, okay, and then how does this fetch work? We just do this, yeah? Mm-hmm, mm-hmm, mm-hmm. That seems correct. Okay, and then these are no longer preload, they become associate. And then they take destination records. This can be source, destination, right? Oh no, this. Uh-oh. Is destination the right thing? No, it's not quite. Okay, so I'm realizing now that the here, oops, the like inverse behavior needs to be part of fetch as well, I think, because well, for one thing, this is absolutely the wrong type. Belongs to at destination like varies based on whether there's an inverse, right? Like it's either a destination repo.record or it's a preloaded result of like the inverse relationship, which means that like the stuff we're returning from fetch is like either in neither case is it this type, which is what we pass into associate right now. In either case, it's like a struct that's not even using it. It's just like a struct with a pointer to that type. So I think we need like fetch belongs to fetch with inverse, and associate is going to be belongs to associate with inverse. We're gonna have to do the same thing here. Belongs to, oh no, this is the without case, isn't it? And then these two. Alright. Maybe I'll make these look more like English and less like convention, huh? Yeah, fetch belongs to with inverse, fetch belongs to without inverse, associate with and without. Alright, let's like name these things. Fetch belongs to without inverse first. Okay, so this is gonna return this like funny thing. But yeah, it's just gonna return an array of these. And is that what I'd hoped would happen here? Yeah. Okay, great. Yeah. Okay. And in the with inverse case, things get weirder. Because I guess we still return the same type. Actually, does it get weirder? Like where do we do? I guess. Yeah, because we're gonna need to know how to like bundle up the results correctly. Either way. Yeah. Okay. And for now, I don't know. I think that we're gonna in the fetch with inverse, we'll perform the associate on the inverse thing. I don't know if any of this is even like vaguely coherent. But yeah, let's like mess with this, right? Okay. So just like take a step back and figure out what we're doing. I'm trying to do this nested preloader to make this spec green, where for a couple of tables I want to associate their results in a tricky way. And so this is modeling like a to-do list app where a to-do can be tagged. And so there's like a to-dos table, a taggings table, which is a many-to-many between to-dos and tags. And I want to be able to say, to do this is like 3 database queries to grab one for all the to-dos, one for all the taggings for all those to-dos, and then one for all the tags associated with those taggings. And this is working pretty well with like composable preloading, where you could like, oops, what am I doing? Okay, composed preloader spec. So like it was pretty easy to say down here I have a syntax for saying I'm going to fetch users, and for those users I'll separately fetch like all the associated records in 3 different tables. And I need a little more abstraction to be able to say, like, in order to do like a nested preload where I'm like decorating the result records and shimming them in later, I need to split the preloading operation into 2 steps. One to just get the raw data, and then one to like attach that raw data to the important spots. because the whole point of the nested preloader is that it needs to like hook in when we fetch the data, but haven't like fanned it out yet to all the parents. We haven't like associated it back up. Yeah, okay, I feel good about that. That's my situation. Inverses make things harder. I wonder if this would have been easier to build if I would have waited on inverses until later. Okay, I'm going to focus on this without inverse case. I think that this is just like all I need. Right? All I'm doing is just like fetching destination records. Only, right, these results are this destination type. So new array of type belongs to dot destination of size. Right, so this now returns like the raw records, but what we actually want are like pointers to those records. This is a real memory management nightmare. I don't know if my plan to think about where we store the memory later is a very good idea. Gotta draw the line somewhere though. Okay. Let's just call it like records. It's like that. Maybe we'll call this like destination records. Is that the right syntax for a new array? No, it goes count first. Okay, and then for destination records, results at index, dot, oh, right. I don't even know the name of this thing is metaprogrammed. That may have been a bad idea. All right, where am I? So here, okay. Ugh, okay, yeah, with, belongs to dot destination inner name. Whew. This name is pretty important for the things to remain coherent, but that is a bit of a bummer. Okay, so this is going to return these like little wrapper structs with a pointer in them. And is that even good? I think that's good. Wait, there's no way this is going to work on the has many case, is it? Because the destination case here is an array already. Like, it's like already been associated. Okay. I think that we need to like define a new type, like a load, like an intermediate loaded type. Like an unassociated destination. Dissociated destination. So the problem that I'm perceiving here is that like the belongs to case was maybe a little bit deceptive in that it's like a singular relationship where like if one table belongs to another, it means that like a to-do has a user ID. And so if you're looking up the users related to a to-do, there's only ever one of them. And so if you want to mess with the list of all the users that we would get in a more raw form, like we're fine. But this destination type in a has many case where you're going the opposite direction, where you want to get like all of the to-dos for a set of users. Each user has a whole bunch of to-dos, and like this destination type describes them as being already clumped up in like little arrays per user, which is the opposite of what I want. So I think that we need like a loaded type, like a loaded but not associated yet type that we're going to be returning. And I wonder if that makes sense in the composed preloader case. It kind of does, right? It's like this ish. It's like a pair of whatever the left-hand side loaded type was and whatever the right-hand side loaded type was. And then it can call associate on each of those. I think that's fine. I think that's fine. Okay. So is it in here that I need to mess with some things? So preloader fetch now returns like loaded, like .raw maybe. I'll call it maybe raw. Like this concept's really hard to name. I'll just call it like loaded. This seems like surely it's the wrong name, but we'll start there. Okay. Yeah. Alright, this seems like... Let's go for it. Okay, so how do we implement loaded on each type is the interesting question now. So has many is the hard... belongs to, I like made all these changes to already, didn't I? Maybe we want to just like revert that for now. Yeah, all I did was try to split these up, and I blew it. That's like unusable. Okay, get this back to normal. Okay, cool. So let's start with has many, and we need to define this like loaded type, and we need to go from there. So I think we still have an interesting issue that it like differs between whether or not we have an inverse. I'm not sure how true that is. Let's like try to not involve inverses in this. So like loaded here is going to be destination repo dot record. And then load is just going to be load has many. And then these are all going to be called associate. And like maybe we're fine, right? Like in this associate case where we can handle either bundling things up into a preloaded result with the inverse from the has many or not. I think that feels good. Okay, so I already have this associate has many. I think that's going to get more interesting. But let's start with just like load has many. And what's it going to take? Oh, this should have been... Oh, wait, why did I call it... Maybe this type should have been fetch. Yeah, that sounds better, because I'm calling the method fetch. It's like immediately confused myself with poor naming choices. Alright. Yeah, this feels alright. This feels okay to me. Okay, so fetch has many. It's going to take a has many. It's going to take some source records, which it's going to do the loading on, and these are going to be of type has many.source. And I think that's all, yeah. And it's going to return an array of has many.loaded. Okay, and I think this method is not very easy, right? We can just look at like the beginning part of either of these methods. We're just going to grab the source IDs, look at the foreign key, and just do this much. This is what I was hoping it could look like. And I confused myself last time around, but this feels about right. Okay, and then let's look at these associate implementations. And I think here I do like a static if, do I? No, I just have this dynamic type to mess with destination records, because they might or might not have had an inverse. And I wonder if I can just do that again. I mean, this would be incredible if I could just like... No, I'm definitely gonna have to do the work in here. Yeah. Okay. Okay, so now this destination records is gonna be a more concrete type. Right, because this with inverse case is where we like really made things weird, and it's because we did the reverse associate during the preload. Yeah. Okay. So let's call this without inverse. And now I think that this type gets a little simpler. Whatever. Let's just leave it at D. I don't want to change more code than I have to. Okay. What if he needs to change here? Maybe like not much, right? Because like without inverse, I think we can call this like has many dot loaded now. Oh no, that still wants to be source. And this is like in the without inverse case is gonna be has many dot loaded. Okay, and what does this do? It for each source record it allocates a preloaded result, and then we iterate over the source records, and then we do the grouping. This is a has many, so we need to bundle them into an array. And then we set this value on each one. Okay, I think that this already does all the stuff it's supposed to do. And it's like the with inverse case is really just gonna like apply. It's just gonna apply, like I think it can perform the same strategy, just like first it's gonna do the inverse association. And you know what, like, I don't know, can we do this better? Can we say, so these destination records are surely going to be now has many.loaded. And then we allocate these new ones. And I think what we want to say here is like, well, this probably makes more sense to say like loaded records. And then I'll say like associated loaded records is gonna be just loaded records, but then like if, this is what we do. If has many inverse of is not equal or is equal to empty inverse, then we do this, else that is a delete. Otherwise, associated loaded records is going to be this business. Associate belongs to. Is this right? This is going to be on like loaded records. And now these become destination records. I feel like there's a chance, yeah? I feel like there's a chance that this is the correct syntax. This like actually does what I want it to do. Alright, I'll just like clear out those. Okay. Man, I am operating at a level of abstraction here that continues to make my head spin. And again, I think might deeply betray the spirit of this language. But like, I don't know, so far so good. Okay, what could I possibly spec about this yet? I think I have to finish this refactor before I can even run my tests. Even if I like comment out this one which fails, I think it's like gonna not be valid syntax until I'm done with all of it. Yeah. Oh, I forgot a has many. I forgot an open curly brace. Oh. Oh. That, and then the real build error was like this needs an open curly brace. Okay, do I have any more of these? Yeah, that one's fine. Yeah, but like I'm sure this like won't even build. Yeah. Oh, but for surprising reasons. Preloader fetch on line 23. What's wrong here? Oh, man, every time. I feel like Someday I'm going to learn how to write code in this language. Loaded is not a member of has many, isn't it? Oh, it's called fetched. I changed it to fetched. Whew! Now we fall apart all over the place. Wait, isn't it loaded? Where do I say loaded? Oh. Okay, now we made it to fetch doesn't exist on belongs to, and these are the build breaks that I was like prepared for. Great, okay. Let's apply this. We got to apply it to belongs to, and we got to apply it to composed preloader, and then I think we'll be all right. Fetch is going to be fetch belongs to associate belongs to. There's no longer this, but we need some fetched type, which is going to be destination repo.record. Okay, let's find this. Yeah, so like fetch belongs to is going to be I wonder what's happening with these. I'm just like, is it really this way that I'm passing types around continually strikes me as the wrong answer, as just like a way to get constant structs at compile time. Because like you can't just have a run directive return a struct literal, but if you call your struct literal a type, you're like fine. Whatever. Definitely makes static dispatch a little tricky to call everything a type. I lost my place. I'm implementing fetch and associate. Great, okay. So fetch belongs to is going to be easy. It's just going to do this. It needs a source records type belongs to dot source. It's going to return a belongs to dot fetched, and it's just going to do this. Okay, I think I'm going to hang out of these for a minute because I'm going to need the like reverse association business soon. Okay, and then here in this associate belongs to, I think these now, I think, did I change this in has many? Did I get rid of that $D? I did, yeah, it's like, gotta be fetched. It's a concrete type. I think I might regret that in a minute, but. Okay. Wait, really? Alright. That seems wrong. Yeah, okay. Yeah, I confused myself. This isn't gonna work. I don't think this is gonna work. I mean, okay, we're gonna have to do like ugh. This is stupid, right? This is a terrible way to do it. Or I don't know, do I do like This seems terrible, but I think this might work. Let's try it. Let's try it. Why not, right? It does feel like a little bit neater to not have two entire like procedures defined for the with and without inverse case. Like a little compiler thing like that does seem like a little bit nicer than a bunch of copy pasted code. Okay, so here we need to do some inverse branching. Let me like grab it out of has many and then like modify it slightly. And then this is to D. D will define here. Okay, this is now loaded records. Oh no, this should be called fetched, right? Oops. This should be called fetched. Alright, and then that seems fine. That seems fine. Wait, no, this should be belongs to. And this should as well. Okay, and this should be has many. Yeah? Okay, there's a chance that that's valid. It's like, there's hope. Alright, and then... yeah, I think that there's like hope. I'll leave this. Yeah, we still have associate belongs to. We've defined fetch. We've defined associate. I'm gonna get rid of this, and I'm gonna pull this up like a little higher. I feel like fetch should be defined first. All right. I don't know. That's like syntax, right? Okay, I gotta do the same refactor to composed preloader, and then I think that's it. I think we're ready. And what in the world did I change? Oh yeah, I was just like tweaking with this. I was like riffing here as I went. It was a terrible plan. Okay, fetch. Dang. Okay, so we need like a fetched type, which is going to be a struct with like a left-hand side. Fetched is going to be of type, I don't know, let's say like it's like pointer to left-hand side dot fetched, and right-hand side fetched is going to be a pointer to right-hand side dot fetched. Fetch is going to be fetch compose preloader, and associate is going to be associate composed preloader, and that is now gone. Alright, and now let's try to split this up. So fetch composed preloader is going to take the composed preloader. It's going to take source records. It's going to return a bracket composed preloader dot fetched. Does this even make sense? Yeah, I feel like the fetch type doesn't want to be an array. Like it wants to... Yeah, like it wants to be like this. Okay. I think fetched... Like I think we don't want to return... We don't want to stipulate that this must be an array, because like it's not always going to be an array. Yeah, and so then in the has many and belongs to case, it will be an array, but it'll be like that. Right? And in the has many case, it's similarly going to be an array to that. Okay. Great, but in this case, it's just going to be like a pointer to each of them. That feels pretty good, right? Yeah, because stipulating that this must be an array, no good for the composition case. Okay, well then this is great, right? So like results is going to be fetched is going to be of type this. And then we can just like set the two, right? So like fetched dot left hand side fetched. You can just call it left hand side and right hand side at this point, right? How did I lose my place? Okay. This is gonna get what did I call it? Preloader fetch on compose preloader left hand side. Wait, why is this not composed? That's a typo. Alright, composed preloader left hand side. Yep. On the source records. And fetched dot right hand side is gonna get the same preloader dot fetch right hand side source records return fetch. Yeah. Okay, and I think that this needs to be like a pointer to that. I don't know. Struggling with memory management. This seems like a disaster waiting to happen, depending on the return types of these. Especially because I'm not like newing here. Allocate that on the stack, returning just a bunch of pointers. These might return pointers to stack pointers. That seems like a bad move. I'm gonna like new it. Wait, but that's gonna give me like a pointer. Whatever. I'm overthinking. I'll fix the memory issues as they arrive. I bet that this caused problems when I recursively composed, though. Okay, associate. Composed preloader. And I need source records. And I need fetched. Destination records is what it's usually called, right? And this returns a bracket preloaded result of composed preloader. Alright, and then this part, I think I just basically copy this all out. The associate's pretty... Oh, we have to like call the associate on each of these. Great. It'll be most of this body. Okay, so left-hand side associated is going to be no associate preloader associate on these and right hand side. Okay, and then I think that these are now, this should just work. This should be fine. Yeah? Alright. No chance this builds. Type on a bracket. Okay, got a dereference. Where am I? 54. Yeah, that makes sense. Loaded records. Where did I even say loaded records? Should have been fetched. Okay. Related destination record equals destination record. Wanted bracket array test user given pointer to test user. Okay. Belongs to line 72. Oh, dang. Alright, what did I get wrong here? This is a belongs to... Let me look at this whole stack. Alright, so this is the part where we are like finding the association and setting it based on if the foreign key matches up correctly. And we're saying that here we want a pointer, but we're actually getting is a bracket, like a pointer to an array of test user. This is in my workspace. This is weird. Okay. Like, how could destination record.id return something? Oh. What's this D? Preloaded result. Belongs to dot. Oh, dang. Right, because now fetched is, yeah, okay, that's fair. I see what's happening here. I'm just gonna hard code this for now. I bet this is gonna cause a problem. But then that'll probably work. But I bet we have the same in has many, where we set D to this fetched type when really we want it to be the singular of the fetched type. Okay, preload composed preloader doesn't exist. Great. Oh, it's in the specs. Composed preloader spec. 126. Should have been doing that anyway. Composed preloader spec again. What line? 260. Okay, weird problem. I'm gonna take a bio break. I'll be back in like 2 seconds. All right. I have a predictable, ridiculous error. That's not real helpful. Let's look at added strings W4. 1197. Oh, cool. I wonder if this is like a... I wonder if this is the seg fault that I was worried about with my memory management punt. And it happened in messing with compose business, yeah? Yeah, I bet this is the seg fault. So let's say that we're not using pointers. We're gonna just like do some copying here. It seems like less to worry about. Because that really rubbed me the wrong way. And this way, we're just going to pass a ton of data up and down the stack. Okay, cool. What's happening here? Oh yeah, I was dereferencing and I didn't need to. Hey, test pass. Refactored. That's the wrong spot. Okay, I've changed a ton. I think I'm gonna... I'm gonna commit all the refactor, but not the new stuff. Source / nested .j and spec nested preloader spec .j. All right. Oh, I need to stop importing this. Gia. All right. Refactor preloaders into a fetch and an associate. Make room for nested preloaders. Okay. Now, let's build this nested preloader, huh? Cool. How's this gonna work? So this now needs different stuff. It needs a fetch and an associate. And it needs like a fetched type, which I don't even know what that's gonna be. But I can uncomment all of this, and I can at least get started. Okay, great. Fetch nested preloader. Takes a nested preloader. Takes source records. That's all. And it's going to return nested preloader dot fetched. And I think that this is at least going to be like an array type, right? And what's this type going to be? Oh, it's going to be super weird. It's going to be super weird. So we're going to fetch like the parent and the child, right? Yeah, that's right. Yeah? That seems right. It's like similar to a composed preloader's fetched type, right? This is reassuring. Okay, and in the first step, we just fetch on the parent, and we just fetch on the child, and that's all. We're good. This feels a little bit, this feels reassuring. This feels doable. I feel like there's hope. Okay, so result is gonna be of type this. Result.parent is gonna get preloader fetch. That's what it's called, right? Yeah. On nested preloader dot parent. Is it capital P? No, it's lowercase p. I think I might want to change that. And source records. Okay, and now this is where things get weird, is that I think for this to make any sense at all, first of all, the parent needs to be like a singular, like its fetched type needs to be an array, which is gonna be hard to write. Like, I don't know, like do we like assert type of parent, like type info on parent dot fetched dot type and like equals array. Maybe we could get there. Maybe that's worthwhile. We'll see. Okay, but importantly, so the results from this in like a trivial sense is going to be like the same as like the result is going to be like this. Yeah, and if the repos line up, I mean, we should just be fine, right? So, I don't know, result.child gets, is this even, this is what I hope I can write. Result.parent. This is what I hope to say. Whether or not this is actually even remotely valid remains to be seen. Yeah? I think that's what I want. Alright, let's get that out of there. Okay, and then associate, boy, I don't know. Associate nested preloader. It's gonna be nested preloader type. Source records. Nested preloader dot source, and then fetched. And this is going to return the preloaded result of type nested preloader dot destination, right? Does that even make sense? Is that correct? Oh, just like of the preloader. Okay. Okay, so for now, let's just say results is gonna be. Let me just go like lean on compose preloader's associate method, and I'm not gonna call associate anywhere even. I'm just gonna new up an array and then not like set important stuff on it. Yeah, and then like what do we do here? Let me just like grab this. I'm gonna say not worrying about left hand side or right hand side result. Is that really? Yeah, not worrying about those. Just gonna say this. So we're not even like setting the destination or anything. We're just gonna like leave it. I'm gonna return compose results. Just trying to get to green. Just trying to get my test screen and see where we go from there. What do we get? Nested preloader line 23. Oh my god, I always forget this. I'm so bad at that part. Alright, like 28, character 5. Oops. One of these days I'm going to learn the syntax. Incompatible structs. Wanted tagging given user. Curious. On line 33. Want an array of taggings, but I'm being given an array of users from where? Did I get the parent and child like order backwards in the test? Where did user come from? Did I fat finger? Did I copy pasta these wrong? What's happening here? Where did user's repo come from? This is all wrong. Okay. Well, that's at least like a valid failure. Whew. That was a much more interesting failure. This sure is a long type. Type is like a novel in itself. Oh boy. Okay. Type wanted. Whew. Whew. How did I get here? Workspace number 4, preloaders.j, line 34, line 29, line 19, nested preloader spec. Alright, I got mismatched types. Okay, okay. Cool. That seems like a valid failure too. So what do we think it is? The to-dos is the wrong type, or the like a diff tool to figure out even what's going on here? Okay, type wanted. Type given. A bracket of preloaded results. Type given a singular preloaded result? Is it that simple? Oh my gosh. Wait, no. Yep. It was that simple. I was missing the array declaration. Okay. Doesn't a tagging have a tag ID? How badly did I write this spec? Oh my gosh. Very badly. Whew. Okay. User ID? Wait, how did that even come up? How are you even talking about users? That seems all wrong. Why? How does the word user even appear here? Why? Why? Okay, users should just be part of fixture data. They should not be anywhere else. This is like the sloppiest test I've written. By far. Alright, to-do ID is not a member of to-do. This feels like actually, I need to like read this code. Okay, to-do has many taggings. To-do is repo, taggings repo, to-do tagging, to-do ID. That makes sense. Taggings repo, tagging belongs to tag, tag ID. Great. What's going wrong here? To-do ID is not a member of to-do. And belongs to? Don't need that anymore. And 32. To-do has many taggings. To-do ID. What did I get wrong here? Like, if I comment out this test, things pass, right? Yeah. Okay, so I'm clearly describing... Why is this a belongs to? What am I doing here? I could not have gotten this wronger. I'm so close. Great. This is not composed results, it's nested results. Alright. LHS associated. Get that out of there. We made it. We made it to green, everybody. We did it. We did it. Okay, but all green does is just to make sure that the count is here. To-dos with taggings and tags. That should be and tags. Great. Alright, I really bombed through that mess. So this is now returning something. It's not doing any of the important associating. So let's get to that now. And I think this is going to be like the hard part. Maybe that's unsurprising. Because we're going to have to like do a couple of tricky association bits. Let's go. So what happened to my music? It used to be stuff I liked. I don't know why Spotify always wants me to listen to Kid Cudi. I'm much less of a Kid Cudi fan than Spotify thinks I am. I don't have like a problem with Kid Cudi. It's just not. It's like every playlist, every radio station eventually becomes Kid Cudi. Okay. We made it to the hard part. Let's start with the specs. This is gonna help me. Alright, so we need 2 to-dos. I'm gonna need probably like a helper to like find the actual to-do that I care about by ID. I don't know, what did I call this? Something like this? Yeah. Okay. So to do with taggings is going to be find to do by ID of to do with taggings ID and to do's with tagging and tags. Great. Okay, and I'm going to expect, it's like description to equal what did I call it? To do with taggings. Easy. Expect to do with taggings dot and then taggings dot count to equal 2. And then I want to like probably just grab the tag descriptions out from the taggings and then make sure that we get the right things, right? Then tag description 0 is going to be to do with taggings dot taggings dot 0 dot tag dot description and do that, and then expect tag descriptions to contain exactly the 2 tag descriptions that I put in the database. And I bet that this fails to build for quite some time. First tag, second tag. Okay. Great. This is the hard part. We made it. We made it, everybody. Bam. Taggings is not a member of preloader result. Incredible. Okay. So, in destination, this is where things have to get super weird. So, let's take a look at composed preloader to figure out the patterns that were helpful there. Yeah. Alright, so like in this case it was kind of easy. We just add like two references together to whatever the current thing is that we have. But in this nested business, we need to get trickier. And I don't think I thought through how the nesting would result in structs yet. So like, what even... Okay, let me just like write down a struct that might work. So we've got using to do, using something struct, which okay, so without the preloading, we would just have using I don't know, preloaded struct, which has a pointer to taggings. Right, but now this can't just be a pointer to taggings. Okay, and so like if we were just preloading taggings tags, we would have using tagging and using preloaded tags or tag. Yeah, okay, so this is like the has many preloaded. This is like the belongs to preloaded. Maybe I'll just call each preloaded, but this is from the has many. This is from the belongs to. Okay, and really what we want is like this subbed in here. We want something like yeah. But this has to be called taggings. Does this make sense? So if I call like a dot description on this, it'll find it on this to do. If I call dot taggings on it, you get that. If I call taggings like bracket 0 dot tag, the tag ID, I got tag ID in here. And if I go taggings bracket 0, does this feels bad though. Why does this feel so bad? This just feels sort of impossible to like glue things together at this level. I don't know. Is this really impossible? So we'll have this tagging from here. And we'll have evaluated the child, so we'll have that tagging from there. Do we just do like an equality mapping and say like if these two pointers even are identical, we like swap? Maybe. Maybe this really isn't so bad. Okay. So how's this gonna work? Well, okay, so first, this destination type, we're gonna have to get interesting here. So... oops. It's gonna be some kind of a fancy struct. Right, and like concretely, the destination type is like that. Like the child.destination type is this. Is that? No, this is the full-on composed thing, like the preloaded type. Yeah. Hmm. The... Okay. So the way that I compose these, I think... Like, these names are obviously going to be hard to replicate, but... Like, how do I map all these back to the concepts that I actually have at hand? So, like... I don't know. This is like... parent.destination name. Am I still messing with that? Yeah. Parent.destination name. And I think I still want it to be that. I wonder if that actually gives me like a different compilation error now. Yeah, like I have... Oh, did I break this? I did. Taggings is not a member? Shouldn't it be? What's the parents? Isn't this still taggings? To do has many taggings. And that's a parent, right? Huh. I figured it would have something called taggings. I bet I'm just like not doing all this right. I don't know, let's just like print out this type maybe. Oh yeah, we can't even do that because we have compiler errors. I'm gonna comment all this out. Just called preloaded result. Great, love it. I'm gonna go type info of it. Alright, what do we got here? What do we got? Let's dig into this. Info struct 16. Break on all the semicolons. Why am I... Okay. What have we got? We got... Let me like break on these two. Okay. Alright, we got preloaded taggings, we got to-dos. How did this cut here? Did I... Nested preloader, preloaded. Did I like forget to save this or something? Why is anything called preloaded? Oh yeah, that's like how it goes. Got it. We have something called taggings, and there's like a using on it, and its type is here. Okay. Oh, wait, we compiled? We printed out. We got preloaded taggings. It's just not very helpful. Okay. And let's like, man, printed all the members. For that dot members. Print member. Name it dot type. Is that syntax? No. Yeah, okay. I don't know. What's not working here? Expected an expression. How do I get that out of order? Well, that's pretty bizarre. Okay, I'm like losing my mind here. I think I want like a better way to inspect types at runtime, but it sure seems like it should have a dot taggings. Taggings. Right, because we're declaring yeah, we don't need that anymore. We're declaring the destination name is the parent's destination name, which is taggings. And nested preloader returns a preloaded result, which says it's got like using that pointer to the source and the actual destination. What is our destination type? It's a child's destination, which doesn't have any taggings. Okay, cool. Okay. I don't know. Using parent blank some type, which is going to be parent dot destination. Okay, what's like the actual struct that we'd want this to be? So given just like the parent and child names and destination types, like we want to like produce something like this. So like, right, so this is like preloaded something, nested, taggings, and tags. Okay, and then this, like, where do we drop in just this much, which is like parent.destination? Can we even? Right? Because like what is parent.destination in a has many? It's like already done all this work and like decomposed down to that. Like for this to work, we need like sort of like a singular of the destination that we can merge in, and then like the destination becomes like a parameterized. this is gonna be weird. I think I'm hitting a wall. I think I'm hitting a wall. It was a fun Saturday stream. It's been a good couple of hours. I think I'm slowly losing my mind. Looping around all the same words and stuff. I'm happy that I decomposed those two. Like, the hard part here is like, the result of nesting this preloader is that the parent's destination is now like nonsense, right? It's like maybe I can mess with the parent's fetched, but that seems like digging too deep. Maybe I can play with messing with the parents, like, I mean, I could demand that the parent must be backed by like a repo. I could demand, and in that case, like, I don't know. But then we're like replaying. We need to then be aware of like whether we are nesting into a has many or a belongs to, which is maybe just the best that we can do. I don't know. What would I like to be able to do here? What would I like to be able to do? Like, what would success look like? I don't know how to describe all these types. That sounds hard. But, like, what does associate look like here? So, I want to, like, associate the parent. On source records and fetched records dot parent. I want a preloader, so let's call it a parent associated. I want to do like child associated is going to be preloader associate on nested preloader dot child with fetched records dot parent and fetched records dot child. Yeah. Okay. And now this type, what even would be the type for this? Like, I'd get a bunch of like this would be, this is like the parents associated type. You get like this, and then you get that. And then I just want to like iterate through. This is a bit of a nightmare, but like, I don't know, like if like, let me like pseudocode it for a sec. So, like if like parent associated, if like the type, if like parents destination type boils down to an array, like either way I want to like traverse parent associated, find the corresponding child associated. Here's what I want to do. I set the source record. That part is easy. parent associated, let's call this like results. Parent associated result for an index. Yeah, because this is gonna this means we've like traversed source records here, and so it means that yeah, I feel fine with this. I feel fine with this. Okay. And then child associated results gets bizarre though, right? Because there's like one of these per parent. And this might be one parent, but it might be like there might be like a bunch of the parents in here. I think I can inspect the type on the has many. Be like, if where all does destination inner name exist? It's on belongs to and has many. Because like the destination name is like preloaded whatever. Yeah, it's like really unhelpful, but necessary for disambiguation. So if I just like lean into destination inner name for now. Man, my head is like spinning. It's really tricky. Just like I've dug my own grave with this like meta-programmed mess that I'm working through. Like what do I want to be able to say here? I want to be able to say like, so I've got this. So like if parent associated result dot like parent dot destination name inner name is like is an array. This is a little harder. But otherwise what we want to do is be like child associated result gets I don't know, let's like define this like this is going to be of type whatever that is. What even type is that? Fine, child associated. Typing out that type is hard. It's going to be from results. Let's just call it like %t for now. Because it's too hard. And parent. Yeah. Okay. And boy, what is this going to look like? It's going to be like 4 results if run like parent I'm gonna assign parent to was it like it dot something, and that something is gonna be like child dot source name. Yeah, which this boils down to like the result dot so the child in this case is like loading tags for the taggings. So it'll be like tagging. And like if parent equals, oh yeah, okay, so actual it parent equals parent, return it. Yeah? Okay. For child associated results and something. Okay. So let's just like assume that parent that like this business is singular. So what we want to be able to do is like, okay, so set the source record for sure. And then we want to be able to set this like funny thing in the place of where the parent record would have gone. I'm going to say it dot like something here gets this like child associated result. Could that possibly be right? Because like no, that's not quite right. If it were two belongs tos, would that even be right? So if we have like, if we want to get to like, I don't know, to.user dot, like what's like a thing a user probably just has one of, like, I don't know, authn. Yeah, and so like, this is all like singular, like to do belongs to user belongs to authn, cool. Okay, so we're like using a to do, the pointer of a to do, using preloaded, nested, users, user and authn. Lost it. Okay. This is going to use user and preloaded authn. That does look about right. And the not nested version would be like, and so really we want to just like swap out Oh yeah, what's the other preloaded thing? That's what I cared about. Using user, using preloaded authn. Okay, so how similar do these things look? This looks identical to that. This looks identical to that. This looks identical to this. Okay, I guess in the nested belong to case, that feels like pretty good. But it gets much harder in this array case, doesn't it? Because in the array case, this just goes straight to a tagging. But is that same? And like, it's not like we replaced this user here. And I wonder, okay, so this is like the double belongs to. And then what about like the double has many case? Let's say like user.todos.taggings. So we'd have like that. And then using tagging. Oh no, this is to-dos. Okay. Should be to-do. And then the nested version is where things get bizarre. Where we have using... wait, no, this shouldn't be... These using just don't want to be here. Okay. To-dos is now this. Okay. How are these identical? Bracket struct using to do using preloaded tagging struct tagging seconds. Yeah, I mean maybe this really isn't so hard. Okay, and so if we have these two results, how do we combine them into this? Is like we take this first one, we iterate over each thing in this to-dos, and we map it to the one of these where the to-dos are equal, like the same pointer equality on those. And then where these have the pointer equality, we shim this, the value for this thing, into that slot in the array. I don't know, this does seem pretty doable, but like, man, what? How in the world am I going to describe this destination? Well, like, so far so good. Child.destination name. Using nested parent and child. I think this is going to want to be a full-on string builder. builder to string on string builder. Great. Okay. So I want to print to builder. That's what it's called, right? Yeah. On the string builder, destination. I don't know. That part can leave outside. We'll just print out the declarations, like the things to fill it in. Okay, so we've got destination as a struct. Done. Okay. Nested parent destination and child destination. And what's the type of this thing gonna be? It's gonna be a struct of the destination inner name of the parent mapping to either a singular or a many woof. Okay. Now we need like an if. Dang, how do we do this part? Like, I want like if type info on parent dot destination. But I need like destination name inner is an array. Parent destination dot something. Okay, so let's go like parent destination is array. Gets run sprint type of parent destination dot something. Parent dot type destination inner name. And like if parent destination type equals, what is type of return? Just the type, right? If like type info of it dot type equals array, then print to builder. Okay, and I'm already missing stuff here, right? So this type that we're defining is the destination type, which is this. Is that right? Yeah, I don't think I need this line here. Oh my god, this is a nightmare. Okay, then I'm gonna print a builder. that is going to be of type bracket to pointer to, and this is just the child type, yeah. Child.destination. Child, like the whole thing though, right? Oh gosh, is that right? So this is like preloaded record of child. Else print to builder. Is that the whole difference, whether there's an array or not? Right, to-dos, array, pointer to struct, user, just pointer to user. Oh wait, but this is wrong, right? This should have been, oh, very loud here. Is this the truth? Or is it actually... Oh my god, I'm losing my mind. I felt like I was really on a roll there for a while. I had a nice time with that refactor, huh? And now I'm just lost. Been lost for a bit. I think... yeah, it feels sort of run over by a train on this one. Let me remember what preloaded record even adds. So here is where we get the using on the source and the destination. I think the destination name, okay. So like this is using the source and this is the using the destination. This is what gets added by that business. Yeah. Because like the destination name in these is like preloaded. And so like really, like it's gonna look like this. And then here, this seems plausible. And so this is going to be nested. It's going to be like preloaded, nested, preloaded, to-dos, and preloaded taggings probably. Based on the silly naming convention that I picked. To-dos is like a pointer to this all. And like this might be because of inverses, something funnier still. I don't know. This feels plausible. Yeah. The preloaded record of the child, is that right? This feels wrong. This feels like I've gone too far. I don't know. Okay, what's our source name? Can't be that, because this is going to result in using loops. preload. Oh no, this is gonna be like nested. And oh no, wait. Source name can maybe be parent dot source name, but this one wants to be nested that and that. Parent dot destination name. Child dot destination name. I don't even know where this leaves things, but I'm ready to run it and see what garbage I get out and try to like push through and then bail. Oh yeah, all those question marks, huh? Yeah, great. I'm gonna bail on this as well. Get that out of there. Okay, line 120. That's all just comments. What am I missing that's important here? What is that? Unexpected end of input and code block? How? It's for loop. Oh, am I not? Did I not like end the this thing? That's done. What code block did I forget to terminate? Oh yeah, here we go. Type info, parent destination type, need a constant type, we got an expression of type string. Right, yeah, okay. Semicolon, type of parent destination dot taggings. Oh yeah, I gotta sneak this in here. And add a semicolon, because that has to be a full statement, not just an expression. Preloaded record. Preloaded result is what I meant. Parent. Oh yeah, and I don't really want to collide. But in this like finder, this wants to be, who even cares? Type P. Alright. Expected equals 0, got nothing. I'm surprised it's like built. It's pretty wild. Although it like, yeah, like failed aggressively, huh? Huh. Didn't I, where did I get 0? On 128.7 in the spec? Sit up straight. Okay, no taggings. I mean, that's about right. That's about what I anticipated here. Okay. Man, am I making enough progress that I want to continue this project? I don't know. But, whoa, wait, hang on. This means that taggings exists? Uh-oh. I might be getting a positive signal, huh? It built. We have something called taggings, and it seems vaguely like it might have the right stuff in it. Yikes. Okay. Okay, so if we have an array type. I want this again. Maybe I'll say like parent or whatever, parent destination. Just gonna sneak this in here. I'm gonna say type info of that equals array. And I think I need this whole thing in this expression probably. Okay. That'll do it. And then here I can say like if, I don't know if making this a static if even helps because it's already, whatever, why not, right? If parent destination type is array, else. Okay, so then here, if parent destination type is array, then do one thing, else do another. Alright, preloader dot that. Okay, cool. So we're nesting. Nested records gets. Let's go for like unnested records. It's gonna be. Alright, so parent records. Parent associated results of it index. Alright. It's gonna be parent. Right, okay, so I gotta go insert run sprint parent record dot something, and it's gonna be parent. It's gonna be nested preloader dot parent dot destination inner name. Okay. Yes. This is going to be unnested records. It's going to be that. And then nested records is going to be a new array of size unnested records.count of type preloaded result of nested preloader dot child. Okay, and then so for nested record index star on unnested record, no, here, unnested record gets unnested records, bracket, nested record index. Alright, and then what I want to do here is like find the unnested record. Yeah, okay, so like for child associated result, child associated results. I think I want this to be a pointer too. I want to say this goes here, right? I think that goes there. Alright. If child associated result, okay. Right, so this is the weirdest part, is we want to find the spot where this to-do matches one of these to-dos. Right? So it's going to be the child's source name. We need to look up the thing with that. So, okay. Nested record, like child associated source is going to get child associated result dot And then this we're going to send in nested preloader.child.source name. Okay, so now we have the source of this. So if that is equal to unnested record, that's it, right? If it's just equal to the nested record, to the unnested record. Yeah. Then nested record gets child associated result, continue. No, just break. That'll break us out of this for loop. Then we're going to traverse through the whole list of nested records and unnested records. I think this seems backwards. Okay, and now I want to set it dot something gets nested records. And I want this to be nested preloader dot, oh god, destination name? Is that possible? What's my destination gonna be? Nested something and something? That can't be right. Do I sneak in? I want it to be parent destination inner name, yeah? Boy, that's confusing. This is feeling increasingly like a huge mistake. What a weird choice it was for me to pick up an entirely new language and immediately try to build something like active record in it. And to do so in like 3-hour-long benders. Whatever. Alright. Let's look at this. Unnested result. Wait, okay. Do I not have some stuff I need here? I don't have this parent record yet, do I? Oh, I do. Okay, great. Okay. I have a parent record. Okay, this is the easier one though, right? Actually, you know what? This isn't even going to come up. Let's just like cut that and see if this builds, and then write a different test for this version. Semicolon expected after expression. Nested preloader line 24. Huh. What? What? Oh. That's foolish. Line 15. Missing it at type. Okay. Declaration claims to be constant, but uses an expression that is not constant. Really? Do I need to like put a run in a run in a run? That's not gonna work. Well, one thing at a time. Oh yeah, that's gonna cause problems, isn't it? What am I doing wrong here? Oh yeah. Found. Oh yeah, I put the star in the wrong place, didn't I? Did I need to do it again? What do I have a hash? Oh, that should have been a percent. Type mismatch. Is it a pointer or not? Okay. Line 106. Here. Hmm. Ooh, I'm close. Unnested resource. Why am I taking a double pointer? Wait, what am I doing here? What's going wrong? I'm getting this wrong all over the place. Type wanted a pointer, type given not a pointer. On line 101. Okay. This, I think, wants to be pointers. Oh my god, this means that it built and the spec passed. No! The spec passed and the harder mode spec passed? What? That can't be true. No, that can't. Huh? No. How? I've just been flailing here. How does this possibly work? I need to print out a bunch of stuff here. Okay, so I feel like I want to print just like everything I can. What even can I do here? I want to like look at these types. I want to... Like, what even is the structure of the data here? Okay, let me like print out this type first. Print to-dos with taggings and tags type info. Type of that. We'll start there. Because if this works, it's incredible. But also, I need to like have any idea of how. Just gonna say array, yeah? Okay. So I'm gonna say cast this to a type info array. Okay, that wasn't real helpful. I think I did that already. Okay. And I'm going to print out then type info of that is going to return, so this dot, like, what's it called? Like element type? Element type. I'm going to cast that to a type info struct. But the thing is that this struct is going to be like inscrutable, right? I've looked at these before. I want to like do that, and then I want to find each of these. Maybe just like that. Okay, I've got a to-do, I've got a nested preloaded taggings and preloaded tag. That's basically what I thought it was going to be. Okay, I'm going to find that. I think I have some belief, some like, this is going to be a pointer to a to-do. That seems reliable. But this... is like going to be some kind of a type info, and I want to grab, let's like pull this out and say element type info is that, and then like for element type info dot members if element type info dot if like it dot name equals this, then say this gets it dot type. That's right, yeah. Yeah, dot type. And then break. And I want to print that. Uh-oh. How do I always forget semicolons? Okay, I gotta dereference it. Let's just call that like a type info. No, that's a bad idea. leave it as a pointer, dereference it here, then figure it out. It's going to tell me struct. Okay, great, that's what I was hoping for. Type info struct. I gotta do some casting probably. It.type cast to like pointer type info struct. I wonder if I can just do like an XX here. Nope. Oh, maybe an XX would work now. What? Nope. Okay. What is this nonsense? I got taggings, which have a type, and that's all. Okay, that sounds about right. Taggings, let's go for like taggings element. That's like for sure gonna be an array, yeah. No, I wanted this. Dot members. Okay. Cast. Alright, so here's where I get weird. I need to cast to type info array on it dot element type. I'll call it just like a type info. Great. Oh my gosh, I never remember semicolons. Cannot cast from a struct to a pointer. Oh, this wanted to be dot type. Yeah, dot pointer. Cool. Cast that to type info pointer. Great. What does type info pointer have? Pointer to. Let's just like do one more here, yeah? So this whole thing, I'm gonna need to do a dot pointer to. Which means I want to cast that and that. This is almost certainly struct. Yeah? Okay, okay, okay. I made it to a preloaded result. This is a bizarre exploration that I'm doing here. What have I got? A preloaded result with a tagging. And a preloaded tag. This is like, okay, I think I'm comfortable with this exploration. I think this did all the things that I wanted it to do. I think I'm going to delete this. I think this was worthwhile, that the types are what I expected, but that we like, you know, We had this thing, we had an array, we grabbed the type of the array, we had preloaded taggings, we had the stuff, yeah? Okay, but it was like more like up here, right, where we had like a preloaded tag. Yeah, this is like tag, yeah. Alright. I feel like I should quit while I'm ahead. Right, like this is already just complete mayhem. But I'm so tempted to do like belongs to, like to nest a belongs to, you know? 'Cause we just like we punted on this branch. And I bet challenging stuff is about to emerge. I bet it's gonna get I bet it's gonna get ugly. Um, is there like an is array? No. There's this constant. I think I'm gonna call it. It's been a nice time. To my one viewer, I hope you're having a great Saturday. What did we do today was nested preloading, mucking around in types forever, building it in a way so that so far you can preload like this. This is what we did. You can nest and say that for a set of to-dos, I want to fetch the taggings for them, and then for each of those taggings, I want to grab the tag on the tagging, which lets you, like down below, do like to do dot taggings bracket 0 dot tag dot description, right? So you can walk all the way through from like all the to-dos for a user through their taggings to their tags to their descriptions, and it's all in there in memory for you. Actually, you know what? I think I want to do... I liked it when I did this before. Just to like make sure that I understand what's happening correctly, I want to make sure to like... I want to like do this. Print SQL select something on prepared SQL. I think this has only ever been a really compelling exercise. But I don't even know where my test is. Hang on. Let me, before I do this, I'm going to do like print about to preload. And then I'm going to say like done. So here we say we're about to do a nested preload. And yeah, these are like exactly the queries that I hope for, right? So we select the ID and the description from the to-dos for the two test to-dos. Then we select the ID, the to-do ID, and the tag ID from taggings, where the to-do ID is in probably the results from these two. And then we select the ID and the description from tags, where the ID is in the tag IDs returned from the taggings. Incredible. Yeah, so we just did those 3 queries, one from each of these tables, to pull out, and maybe it's worth noting that like, even if we had like a ton of other tags or taggings or to-dos, I don't know, like, why would I copy that one? Like, what do I want to do here? I guess it's sort of hard to build a compelling one of these because, like, I'm intentionally only selecting these 2 taggings Sorry, these two. I'm only like selecting these two to-dos in the tests. Like if we had a bunch of like irrelevant tags, would that be interesting? But here, let's say I'll add like to-do with no taggings ID. I just want to like prove to myself that there is any point in doing this work. So if I insert more, oops. What we should see is like more arguments. Yeah, right? Like we need to find more tags. But we should have done, we did no more SQL queries. No n+1s here. There's no way to even express an n+1 with a set of tools yet. Okay, I feel great. I'm gonna call it. Our nested preloads do the right thing. Wait, that's not wrong. There. I wonder if I have a to-do here. I think I missed when I did like this like prepared SQL business. Like I think I want the replacing question marks in certain cases with $signs and flattening out. Probably to happen with an execute. That feels like more of a Postgres concern than like a abstract SQL concern. Anyway. Let's do this, like implement prepare SQL placeholders for args. Oops. In like execute, not as part of SQL select, etc. Right? I kind of like throwing question marks to my Postgres wrapper and having like a, I don't know, maybe I want like another compatibility layer in between or something, but what am I doing? I'm in Unix. Alright, what all have we done? We added a spec. We added in a load into main, and nested preloader we implemented. We deleted a line in SQL select HA. Okay. Support for some nested preloading. Well, that was a real session. The code's up. I think I'm done for now. Bye, friends.